In third grade, students start formally working with multiplication facts with products up to 144. So thinking those single digits as well as 10, 11, and 12. So what's often referred to as basic multiplication facts. And by fourth grade, there's an expectation that they can find those products with automaticity, that those products just start coming automatically. And for a lot of students, this is one of the toughest things that they kind of first face, and then this impacts a lot of the work that you do in mathematics after third, fourth, and fifth grade. So this strategy is going to look at a way to think more about number sense rather than just memorizing what those facts are, so that when students do forget, maybe they're stressed out or maybe they have a hard time memorizing facts without making those connections, that they have a strategy to go to. So I've got 3 facts here on the board, or 3 expressions that we're going to look at, and these are 3 of the most missed facts. If you look at any third or fourth grade classroom where they have those benchmarks, and even fifth grade and on up, students struggle a lot of times with those 6s, 7s, 8s, 9s, and then the 12s as well can often be a bit of a struggle for some students. So we're going to look at this strategy for single digit multiplication, where we are going to multiply with friendly number partials. And a lot of times you might think of partials as a multiplication strategy just when we're dealing with larger numbers that we can decompose often into just their place value. We can multiply a number, say by 23, if we decompose that into 20 and 3, but we can also do that with single digit numbers. So we're going to look at this partials strategy for multiplying most of the numbers here, single digit. We do have 12 as well, because that's also in the benchmark. And we're going to use a ratio table to sort of organize that strategy as a way to model the thinking. And so we want to think of some friendly numbers. And so a lot of times 7 times 8 is a fact that students have trouble memorizing or often forget. A lot of those 6, 7s, 8s, and 9s sort of blur together if you don't have the connections. Where 7 times 8 is a fact that maybe doesn't come to me right away, a more friendly fact, a more friendly number for me to work with might be something like 5 times 8. 5s are typically a lot more friendly for students, and I want to build my way up from 5. And so again, I'm going to use a ratio table to show this, and I'm just going to mark the beginning of my ratio table with a 1 and a 5 to show, or I'm sorry, with a 1 and an 8 to show that I'm thinking in 8s, and I'm going to build these 8s up to getting to that 7. I want to figure, I need 7 groups of 8, and I'm going to build my way up there. And like I said, 5 is a pretty friendly number, and so I'm going to start by thinking about 5. And I know that 5 groups of 8, or 5 times 8, is 40. Really friendly, easy one to work with. Another really friendly fact I know, another friendly number to work with, is 2. And the reason that I think of 2 is if I can combine my partials of 5 and 2, that's going to give me that 7. And I know that 2 times 8 is 16. Even if that's a fact that I'm struggling with, I could maybe skip count by 2s to get up. That's a little bit lower of reasoning than students should be working with, but we are still thinking multiplicatively when we're using partials strategies like this. So it's okay at first if students still have to maybe skip count by 5s or skip count by 2s to get these facts until they're more automatic with that. And here's where the power of the ratio table is, and the power of this partials strategy can be. I know that 5 and 2 is 7. And since 5 and 2 is 7, those are the partials that I want to work with. If I can combine my groups of 5 and my groups of 2, I'm going to get 7. And so all I have to do is combine 40 and 16. A lot of 5s are really easy numbers to work with. Many of them are also 10s. Every other 5 is a 10. And so 40 plus 16 is 56. And now I have 56. And so this is a great strategy, again, to start learning some of those more complex or more sophisticated facts. Again, the 6, the 7s, the 8s, and the 9s are often ones that this can be really helpful, but also a great strategy for students to just have in their pocket if they do forget a fact, even once they have learned and are more comfortable with multiplication. We can just think, how do we break one of the numbers apart into something that's a little bit more friendly, into 2 friendly parts? We find those friendly parts and we put them back together. I'm going to jump down and show that again with 9 times 6. I'm going to do this one a little bit faster. And here, I think I want to break apart that 6. I really like 5s. If I can get 5s, 5s, 2s, sometimes 3s and 4s, 1s, those are all really easy, friendly groups of numbers to work with. So since I'm going to break apart the 6, I'm going to be thinking about groups of 9. And again, my goal is getting to that 6 because I'm doing 9 times 6, but I'm going to break this apart and I know I'm going to get to 5 and 1. I already have 1. I know one group of 9 is 1, so all I need to find is 5 groups of 9. I know 9 times 5 is 45, and then now all I have to do is combine my 1 group and my 5 group because I know that will give me 6. 9 plus 45 is 54. So there we go. Another fact that, whether we're just learning these facts and we're experiencing this for the first time, or it's facts that maybe students are struggling with, or they just need a strategy for when they do forget, this is a great one to go with. It also works with some of the larger facts like the 11s and the 12s. Often students don't struggle with 11s, but 12s seem to be an area that some students struggle with. And so we can use that same strategy in what might be a little bit more of a familiar way to use partials, because we can just break this apart into its tens and its ones. We can break it apart by place value and think of those groups of 6. I know that 2 6s is 12. And I know that 10 6s is 60, so if I combine my 2 6s with my 10 6s, because 2 plus 10 is 12, 12 and 60 give me 72. So I know that 6 times 12 is 72. And that's our friendly partials strategy for single-digit multiplication.